Hello, people. Now that I'm in self-isolation and have nowhere to go, I decided to do a few video segments which are anomalies with respect to the stuff that you find in this channel. Generally speaking, the things that I have included in the channel, majority of them are on the FEA side using CATIA and on the mechanism design on CATIA. There are some there are some miscellaneous type of CAD related issues, but this is another one along that line that I would like to do. So let me explain to you what the problem is. I always wanted to do something like that, although on YouTube there are some excellent tutorials along this line, and I don't pretend that this is better than them. In fact, some of those other ones are better. But anyway, I want to put my 2 cents of worth of CATIA in this particular problem. So we have a block here, and which is on a track. So this block travels along the track uh, as a basically a prismatic joint, and eventually it will reach this left side and it will clash with it. Okay, so what you want to do is how do you detect clash and interference in CATIA? And the first one that I'm going to do is primarily uh, uh, this particular problem using both assembly design tools and then digital mockup tools. The parts are really simple, so I'm going to make it here. And let's see now. I'm not going to worry about dimensions, so let me start with the product uh, product product file. There we are. There's the product. Insert my first part, new part in there, and I'm going to call this thing the track properties track. Don't worry about dimensions, okay? And track. Okay, so let me make it. Let's go to part design. On that vertical plane, I will sketch what you saw in this slide. Okay, so something like this. Okay, there we are. All right. Exit and path it. Let me double this. Okay, good. So this is my track. Now I'm going to insert the second part, which is just basically a box, a block. So insert, new part, say no, and let me call this thing the block. Properties, block, and block. Okay, let's make it. So on this plane, I will sketch. But eventually, I have to assemble these things, so it really doesn't matter where I do this. So I'm going to draw a rectangle like that. Exit and pad it. Okay, very good. And let me change the color on this. So let me turn it like perhaps this. Okay. And we're going to save everything. File save management. Save as. Desktop. New folder. How about making it April 4, 2020. COVID-19 lockup. All right, let's do the assembly. So first of all, let me anchor the base or the track. I anchored it. And I'm going to bring this thing and put it there. So coincidence between this edge and that edge, update. And coincidence between this face and that face. Because eventually I want to make a, when I go to DMU, I want to make a prismatic joint out of that. Okay, this is pretty much it. Right. So let me save this. Okay, we are at the assembly design, in the assembly design workbench. Notice that there is some toolbar here which says space analysis, and within it there is something that says clash. See that? Clash. So there is a space analysis toolbar. This, the one on the left, it says clash. You click on it. Well, first of all, you can give it different names. So I'll call it my first attempt. It was interference 1, so I give it a meaningful attempt, meaningful name. And you can do contact and clash to identify contact surfaces and clashes, and or you can do other things, or other things, which this is what we're interested in. And between all components, okay, you can do it between selected components, so we're going to do between all components. And then you say apply. Now what happens is that, notice that if you zoom in, you see there is no clash, but there is a contact between this block and the track that you see. As a matter of fact, I put a contact constraint there. And if I say, for example, if I say filter but show me clash, there will be none. If you say contact, you will see that it is actually right there. And if you say all type, of course, the only thing that you're going to see is contact. All right, good. So let me close this. Remember, you have to say apply in order to get this report. And down here, under the applications, we get on the interference, we get this thing that I create. Good. Now, let me go and use the move and manipulate. See this? Move and manipulate. This is the toolbar which says move, and this one says manipulate. Make sure this box is checked because I want to move this thing and all assembly constraints to be respected. Now, of course, for example, if I wanted to move this thing in the Y direction, it won't work. It won't work because these two faces were coincident, and therefore now, but the only thing that sorry, if I wanted to move in the X direction, it won't work. See that right there? If I wanted to move it in the Y direction, Z direction, it won't work. You can see it won't work. Make sure this is checked though. Now, if I say Y, there is no problem right there. You see this? Good. Now let me move this thing all the way to the end until it reaches this box, and it will go through it, because it doesn't detect that interference, that clashing. Okay. Now notice that here, if I left it there and I say OK, and I double click on this branch interference rules, it says that let me see now, there must be interference. This is all types, and right there it says we have contact, and if I see clash, right, it doesn't detect it. Now, well, actually, let me take back what I said. Notice that you say, well, wait a minute, these are interfering, so why am I not getting anything? It's all getting contact, because you have to click on apply right there. Don't forget to say apply. When you say apply, contact, clash, right there. You see that? I had to say apply in order to get this clash detected. And this number, 14.97, is roughly the amount that it has penetrated that piece. Okay, now, just to convince you, say okay. Move this thing back. Move this thing back to some other location. say OK. If you double click on this, and now it says clash because you have to say apply in order to update that sheet, okay? And there is no clash, but there is a contact, of course. There is a contact because I created this. I made this face coincidence with that face, which means that there is a contact between them. All right, good. Now, let me move this thing a bit further, right there. So this is one way of doing it at the assembly level. In the event that you have a digital markup license, what you want to do is you can go, if you want to create the mechanism. This is a very simple mechanism, it's just a prismatic joint. You go there. Let's create the joints. I have a lot of video tutorials on mechanism design, so I'm going to say assembly constraint conversion, new mechanism number 1, auto create, OK. And not surprising, this is going to be a 1 degree of freedom with a prismatic joint. So I'm going to double click on this and make it length driven. Flip the arrow. I mean, you put the cursor on this blue things that you see here, arrow that you see here, it flipped it. Okay, so it moves in that direction when you drag the sliding bar, as you will see in a minute. Now, here's the simulation that has been created. There's a couple of things that I can do. First of all, notice that if I click on let me see for a second. If I see that this thing that you see right there is the same clash icon that we saw before. Now I don't want to create it again because I've already done that. So cancel this. Okay. Let us go and create a simulation. See that? Create a simulation right there. Mechanism number 1. Okay. So I'm going to move this. I think I better change the range of this because 100 is not very good, not enough. So let me try 200. Okay, so good. So let me drag this thing. Notice that it got there. Insert. You insert it. These are things that we have done in mechanism design tutorials. And change it to anything but 1. Notice that you can play it. It goes through it. Doesn't understand. No problem. Okay, now what I want to do is I want to make sure that this actually will detect any clashes. So notice that here there's a box here which says edit analysis. See that? Edit analysis right there. And this interference space is dimmed. So you click on edit analysis and then you say add. Notice that it sees that there was an analysis that I made initially called my first attempt. Say OK and close it. And notice that now this is no longer dim. But it says off. It says off. There are 3 options: off, on, and stop. Okay. Now, so let's play it. Let's play this. Rewind it and play it. Nothing will happen because the interference detection is off. Rewind. Now you can say on and play it. Here you see that when it reaches that, it will actually, something will happen right there. See that? It shows you, first of all, these 2 are highlighted. These 2 parts are highlighted because it detects that there's interference between them, but it doesn't tell you where, really. So rewind, play it again. See? As soon as it hits it, the 2 become highlighted. The 2 parts that are interfering with each other become highlighted. Now, if you say stop, so when it hits it, it's going to stop. It won't penetrate through it. Good. Okay. Now, let me go back here. All right. Now, there is another way of doing this thing to get more information. And that is down here. You see this down here? It says clash mode. Okay, clash mode. So if you click on this simulation, so that I'm sorry, not that one. Let me see now. Where's my mechanism? Sorry, simulation. That's what I wanted down here, right here. If you double click on this, these two open up. Okay. Now, first of all, I put this thing back to off. Okay, I put it back to off. All right. Now, this one says clash detection off. So fine. So off. Okay. And this off has nothing to do with that off. So I'm going to select it and play it. Change this thing to anything but one. Nothing exciting happened. It goes through it. It goes through the part. Fine. Rewind. Now, here, you click on it. Okay, this still says off, but I clicked on this, which says clash detection on. So play it. As soon as it reaches it, not only they both highlight, it also shows you where the interference or clash region is. So let's see. Just look, watch the top. See that? See that? I guess it doesn't highlight, but it shows you that the interference is between these red is described by these red boundaries. Rewind. As a matter of fact, this one says clash detection stops. So when it detects clash, it stops. Again, remember, clicking these have nothing to do with this, okay? When it reaches there, it stops. And it shows you where the clash region is, right there. Good. Now, there's one other thing that I want to do, and that is the following. It is possible to get this information a different way, and that different way is, let me see for a second. Right, you go to simulation with command right there. When you double click on that, it gave you the simulation, right? I don't want that, okay? I want simulation with command, which allows you to activate sensor. You might say, well, wait a minute, can I not get that thing from here? Let me see. The problem is that, well, I guess you can also do it here. Fine, activate sensor. Either simulation with command or activate, or just double click on this guy and say activate sensor and select here clash. See that? Clash right there. You select it. Don't close this window. Okay, so drag this thing to where you want to go. Okay, let me drag it, reset it. I changed that to on request. That's not necessary, but I did it. So I moved this thing here because I said on request. This will not move until I click on the arrow right there. Okay, obviously they made an interference. Both are highlighted, but here, once that happens, you're going to say graphics, and it shows you that up until a certain point there was no clash, 0. Then there was a clash, okay, and pretty much this is another way of getting that information, except that it's not as I don't like the way this thing looks like. However, it's you can play with it and find out whether you can make sense out of it or not. So this is another way that indicator graphing it gives you some idea. Now I'm trying to see. I didn't like the fact that there were 2 of these, but let me see for a second. Can we play this thing? So let me rewind. I have a feeling that reset it. Okay. Clear the history. Okay, good. Play it. Move this thing and play it. And now graph it. See if you get the same effect. Ah, there it is. I think I did this thing twice. I dragged that thing twice inadvertently, so it makes sense. So there is no clash until it reaches that wall, and it goes through it during the rest of the time. Okay. The reason I got that double hump is because inadvertently I did this thing twice. I want to remind you that I didn't have the on request on. I dragged it, and then anyway, you get the picture. Now, I will do another one which is a little bit more detailed than that.